Alright, so let's finish up these slides. We're talking about Java. Java's weird. We know a little bit more about it now. Let's make a counter class in Java. Remember we did that as like a first example of how we work with object-oriented programming and making classes in C++. So let's do the same for Java. In theory, that will be nice. So let's make a constructor for a counter class and like a get count method, an inc method, a reset method. So let's try to make all that happen. And the idea is like every counter object should hold on to its count. Starts at 0, and then you should be able to say like c.inc, just as usual, right? A little counting device. Inc to make it bigger, make it 1, inc it a few times, right? 1, 2, 3, whatever. And then I'll make a reset method to reset it to 0. c.reset. So that will make it 0 inside the count. And then also I want to make a reset with a parameter to show you there's a difference between C++ and Java when we do this. So I'll have it pass along 42, so we'll like change it to whatever the user passes if they run that version of it. So that's the kind of interface I want to give. So let's do that. Counter for Java. If I want to make a counter class and it's called counter, you better believe it's going to live in a file called counter.java with a capital C. Boop. So here we go. It must be called public class counter. And we will have a main function. I wonder, does this have, yeah, there's a snippet for that. Public static void main, string bracket bracket args. There you go. We're going to have a main function, but this is not the counter class implementation. It's a static method. It's part of the class. It's not really a method on objects of the class, if that makes sense. So I'm going to put counter methods in here, like real counter methods in here, because this is the counter class. I'm going to make counters in the main function. I'm going to do something like this. I'm going to say like counter C equals new counter, because everything is on the heap in Java. Okay? And I want to be like C dot, or first of all, I want to print the current count, so system.out.println c.getCount, all that fun stuff. So that should print 0. And if I inc it a couple times, 1, 2, let's do 3 times. Now it should print 3, right? If I print the current count now. So this is how I want to use the counter class. I got to build it still. Let's do reset and a couple inks. That'll make it 0, 1, 2 now. So we should see 2 if we print it there. And then I want to do a reset to like to a parameter value, to an argument. So 42. We will need 2 separate reset methods for this. You only need 1 in C++. So I'll show you that. So there's that, and that's good enough for now. So let's get the counter class working with these operations. So we need a constructor for our counter class. A nice thing about Java is you don't have to like, where do I see this? You just start implementing in Java. I think I told you that. You just say stuff. You don't have to declare anything. You just say that it exists and give it a body. Any order works. Java doesn't care. So there is no such thing as function/method declarations in Java. So you just start writing it. That's fine. It'll find it. And also, there's no concept of public colon, like make all these things public, make all these things private. You got to say it next to everything. You also can't say public colon or private colon. So that's no fun. And so that means you have to put public/private next to everything. So, all right, we're making a counter class. I want to use it. And so what's the one piece of data I need to store in my counter objects? I need a private member variable called count. So it's private int count. Just like that. All right, so we'll need one field called count, and count is private. You got to mark it like that. All right, so it's not horribly different. And then we need a constructor. We need a constructor for counters. And that is exactly as you would expect in C++. Like it was just, you say the name is counter, but it's a public method, right? Constructors are public. We want the user to see those. So it's public counter, parenthesis, parenthesis. And what should the counter do? There's no like initializer list. It should set the count to 0. That's what a constructor for a counter object should do. Set our count member variable to 0. So count equals 0. So every object, when you make it and it's a counter type, it will have its count set to 0. That's kind of cool. So notice this is the only static method. It's different. These are public things. They're not marked static. They're part of objects, part of counters. Okay. So let's do get count. Public int, right? Get count gives back your current counter's count. Return count. That all looks the same as before. You normally mark a getter as const in C++. Const does not exist in Java. We can't mark a method as const very easily. There's a way with some like annotation tricks, so like you use @ signs and things, but that's beside the point. It's extra work. It's not the same. So that's our get count. And then inc public void inc should, when you inc a counter, should increment the count plus. And then reset. I have used 2 different kinds of resets, and in C++, what you can do is you can write just one reset, can't you? Have you read about default parameters? Have I forced you to use those yet? So you could be like public void reset, and if you give a value like int new count, and like count equals new count, pass along something. In C++, you can say this. You can say new count equals 0, and so if the user doesn't give a new count argument, it will just call it 0 and make it like that. So you only need one reset in C++. In Java, this does not work. There's no such thing as default parameters. So you need 2 separate reset methods. You need this one and one that has no arguments. And that'll just set it to 0, whatever you wanted it to be. Java doesn't have default parameters, so you have to make 2 separate reset methods. Right? But everything else is very similar, right? And then here we are in the main function, using all our stuff. Making a new counter, running its constructor, printing the count, inking it, resetting it, doing all those things. We should see what we expect. So Java C counter.java. I will create counter.class. Boop, right there. And then I want to use that, go away Zoom. I want to use that and run it with the Java command, Java counter. And there we go. We get our 032. Sorry, this was not supposed to be 2 anymore. This is supposed to be 45. So that was correct. So we reset it to 42, make it 45 by inking it 3 times. So yeah, that's a counter class in Java. Similar yet different. Any questions about that? Alright, let's do some more. Sadly, one thing that I don't like Java for is that they don't give you operator overloading. So if I had 2 counters and I wanted to say what it means to add 2 counters, I could not use the plus operator. Very sad. So things get very long-winded in Java because of this. You got to say like, instead of operator plus, it's dot, like give it a name. You got to say dot add, and it looks a little weird. Like C dot add it to C2. That's as good as it gets. You got to make it a method. So let's see here. Where do we want to put? Let's pretend we have it. Let's use it. Here's how we'd use it. Counter C2 equals new counter. And then ink that a few times. Oops. So we got 45 in C, and then C2 is holding 3. So if I add them, counter C3 equals C dot add C2. That should make a count of 48. Yeah. So if I print that, then I should see 48. If I print C3, C3's count. Oops. C3. 6, 7, 8. There. So that's how I want to use it. So let's make this method an add method. So it's public counter returns a counter called add. And so it takes another counter other. There's no concept of const. There's no concept of references. I guess everything is a reference as far as Java is concerned. It's a different kind of reference. And so when we get called, like somebody's saying c.add c2, and we're jumping up here. So we have ourselves, and we have the other guy. Okay. So we need like a sum We're going to add our count to the other's count, and then we're going to put that in the other counter, the one that we're returning. Sum count equals our count plus others count. And then we're going to make a new counter. Counter res equals new counter, and let's reset that to hold the sum count. Useful use of that method. So, and then return res. So that's our addition, and that should do it. So let's compile and run that. Java C to compile, and then Java to run it. It's got to run it in the Java virtual machine. So I do get my 40 just like that. Hopefully that's not horrible, right? Public, it's returning a counter. Very, very similar to how you would write it in C++. So there's that. I think that's all I want to show you about that. So here's a nice long table of things, table of differences. I think I've said a lot of these, though, between Java and C++. Thank you, Bill Kearney, the other computer science professor. I stole this slide from him. So first thing, Java is not compiled to machine code, right? It's compiled to an intermediate language called Java bytecode. You can't say /. That's why I haven't been saying // counter.class. It doesn't work like that. It's ones and zeros. It's a binary encoding, but it's not capable of running on our CPU just yet. So that's like a step above, and so you got to run it in Java, which I guess it takes slightly longer to run compared to a C++ program when it's first starting up. It's got to be compiled on the fly to machine code, and then instead of const for variables, so you want constant variables like pi or something, you would probably make it part of the class. You'd make it static. And it's going to be public because you want everybody to see it. And then it's final. Final instead of const. Final means you can't change it after it's been set once. That's its final value. And then instead of char, they say byte, because chars take up a byte. I guess that works. And yeah, no pointers. Everything's on the heap, though. You're getting back what Java calls a reference, which it's somewhere in between references and pointers for us, for C++. But you just use the dot everywhere. There's no arrow. There's no it knows everything's going to be on the heap. No operator overloading, so sadly, we don't get that. That would be really nice to have. And yeah, I'll show you this in a bigger example in just a second. But instead of including a library, you import things. You import your libraries, and they're called packages as far as Java is concerned. That creates a namespace as well. Package is the equivalent of namespace in Java. And we import packages. And we get everything from that namespace available for us. Every class that you make, just by default, even counter, we didn't say anything special, but by default, it inherits from a special class called object. It's like the class that everybody inherits from if you don't say anything else. And so this is a concept you'll understand more when you take CSCI 41. But do you remember how like every IF stream in C++ really was secretly an I stream and inherited stuff from it? That's the kind of thing that's going on. Feel free to read your book about this. It's an interesting concept that you will need one day. But in iStream is where that extraction operator lived, and so that's why it existed in IFStream, because you got it for free from somewhere up here. So that's the kind of thing that's going on here. It's like we made a counter class, and it inherited from object, and it got some stuff for free. We just didn't use it. So that's what happens in Java. Everything is inheriting from object. I think I showed you the documentation pages last time we got this guy. It's very long. There's a ton of stuff. So this was all generated automatically. You write code and you put some comments in special places, and like all of this, an entire website dedicated to documentation gets created from your code, which is really cool. That doesn't really exist very easily in C++. It's not part of the language, at least. But Java really likes that. And there's also, most people don't write Java in Vim. They use an IDE or integrated development environment, and that hooks into the compiler in a very cool way, and it like highlights issues and tells you interesting things. It hints at what you want. a lot of the time. And so that's a fun thing that is very, very nice about Java. So those are some good things. And then also, the reason we don't teach you Java is because you would get lazy with memory. Because of that garbage collector, you don't have to say delete, right? You just say new everywhere, and I'm not leaking memory, even though I'm saying new. Even though I'm being like, all right, new counter up in the add, new counter every time I make something. I'm not leaking anything because Java will notice once I'm done with all these things. Once I don't have access to them anymore, it will get rid of them for me with the garbage collector. And so that we definitely want to teach you to manage your own memory in this class. That's one reason why we don't teach you Java first. Yeah, and then the standard library, like the names are long, but hopefully you can see, right, how many things you get. You do not get this many things in C++. This is amazing. It's ridiculous. These are different packages. As I click on something else, like it's going to expand to more things again. So this is crazy amounts of cool stuff. And that's why a lot of big enterprises, they like Java because it's like batteries included or whatever. So yeah, those are some differences. And if we are happy with that, I would like to teach you a very nice thing that we haven't been able to do yet because it doesn't exist in the C++ standard library, but it does in the Java standard library. Let's make a graphical user interface, or GUI for short. Let's make a program that actually has a window that opens when you run it, that you can click stuff. We've just been making terminal programs this whole semester. Java makes it easy to write. There's a library built in that we can use to make actual graphical windows to do stuff. It's called the Swing library, a cute little name, and I'll show you some pieces from it. Right? So here's the setup. Here's what I'm gonna do. I pre-made this, but I'm gonna explain it to you how to do it. But let's make a GUI, or graphical user interface, for our counter class. I think that's the easiest thing to do right now. So what we're going to do is we're going to make a counter object in our main function, and that's going to be like our ground truth. That's going to be like our database. It's got its count deep inside, starts at 0. Every time you ink it, it adds 1, right? What we're going to do is we are going to make a window that hooks in, that like reflects this counter object deep down. Like this is our database, and like this is the presentation of what's going on in it. We're going to make a window with 3 buttons. Or sorry, not 3 buttons, but one text field that shows the current counter's count, and then a button to increment the counter, and then a button to reset the counter. And so if you click ink, what it's going to do is it should update the database. Like this is our ground truth. It'll make the counters count 1, and it'll refresh the screen and display 1 on the counter's count. That'll be really cool. And then if you press reset ever, that should just bring the count back to 0. First updating the counter's count, of course, and then like this will reflect always the underlying counter's count. Okay, that's what's going on. And so let me show that to you. I've made it already, and it's going to hook into our counter class. It just notices that it exists in the same window, in the same, what's it called, in the same folder. Because I'm running all this on my Linux virtual machine, I'm SSHing into this right now, so I need to run it on here, like, because this is where the windows live, and it's never happy when I first, there it goes. So let's do this. Let's go to the same place in the terminal here. Oops. So I'll go to 4029. So here's the same folder. I've already made this file. I'm going to show it to you in a second, but let me just show you what it does first. Java C counter GUI.java. That'll compile it, and then I want to run it. And it's going to hook into both our counter, a precompiled counter, and then it's got its own thing. It's got its own main function. So Java counter GUI is what you say to run the main function there. And here's what we made. Here's what I'm going to show you how we made it. It makes this window. It's called counter GUI, and it displays like it's got a counter deep down, and that's like the database. And when you click a button, it updates the database. It updates the counter. It like calls ink on the counter for real, and then it refreshes the screen and shows you the new counter's count. And then of course reset would reset it back to 0. So that's the silly little program we're making. And hopefully that seems a little cool, right? We haven't been able to do that yet. So let me show you all the pieces that are involved for that. So we're using a library called Swing, and it gives names to all these different pieces of a window. For example, like the window itself, you just scroll down in the library. They all start with J, by the way. The window itself is called a J-frame. It's like we're going to make a J-frame object and eventually put stuff inside of it. So this is the frame. And then inside of a frame, if you want to put a bunch of stuff and like have them not like be on top of each other, you have to organize them in a hidden thing. It's like, it doesn't show it to you, but like it organizes things. It's called a panel. So inside of our window frame, we're going to make a J panel, and that will allow us to arrange different pieces. They're called components horizontally. And then these three things are other objects that we'll make, and they'll turn into things on the screen. So this is a J text field. If I make a J text field object, add it to the panel, add that to the frame, then it will put that in the window. This is called a J text field because it stores text. And then these two guys are J buttons. J button. Both of those. So yeah, you got all those things. Here's like J button. It corresponds to a button that you can click on, which makes a lot of sense, I hope. Yeah, so let me show you the code for this. It's a little weird. You got to learn the library. It's its own little specific thing. But here's what it looks like. So if I look at counterGUI.java, of course, there's a public class called counterGUI, but first we have to include the things that we need. So Java Swing, javax.swing, that's where this stuff lives. I want to import everything. It's not include, it's called import in Java, also in Python. So there's that, and then I need this other line for events. An event is what happens when you click a button, and so we need to hook into those two, so we need both of these things. Also, some types from both of those, some classes from both of those libraries. And so here's counter GUI, and so deep down, we're going to have a counter. This is going to be the counter that is our database that like the window is going to reflect, so let's make space for it. We'll make it static so that it belongs to the class itself, and like we'll use it in the main function. Everybody can access it down there, that's fine. So we're going to use a counter under the hood to keep track of our data instead of our GUI. It will always reflect what is on the screen. That's what we're using to store that stuff. We don't have to say import counter or anything like that because it's in the same folder. Java knows where it is. It can find it. That's cool. And so a static field, when you say static, anybody can see it. That's how you make a global variable in Java. It belongs to the class itself. All right. So read more about static in your textbook if you'd like. But it has the equivalent effect in C++. Right? So in our main function, when all this starts, we make a new counter object and put that into C. And then we start building our window stuff, right? So I make a J-frame first. That's going to be the window itself. And you can feel free to look at this documentation when I give you the link and everything. But a J-frame, like one of its constructors, it's just code that turns into a window. That's all it is. One of its constructors takes a string, and that will be the title of the window. So the thing that appears up here, like J-frame up there, and all that. So that is here. We're going to call it counter GUI. So we're going to make a new J-frame object and pass along the counter GUI string, and that will be the title of the window there. And then for some weird reason in Swing, in the Swing library, pressing X on the window doesn't actually close the window. So we would like that functionality. So you have to say specifically, okay, when somebody presses the X, please close. You got to like set default close operation and then pass along some constant that means please close it when you hit that. And yeah, that's how that works. And you can see why the meme is Java is just long-winded. And you just have to say so much on a single line. There's so many things to say. So there's your frame, and then inside the frame I want a panel that will hold things and arrange them horizontally. So I make a new J panel. I'll put stuff in order, and then I start building the pieces that will exist inside the panel. So I need a text field and two buttons. So here's the text field. So the constructor parameter to a text field is like how many characters wide do you want it to be able to show you information. So this one is 3 characters wide. So you see how it's got room to store at least to show you at least 3 characters at once. And that's if you kept pressing increment, you would get to 3 digits at least, at the very least. So there's that. And then here's the counter GUI. You see how that's the title of the window there? And then we don't want that text field to be editable by the user, because usually you make a text field like you can type in it, but no, we want to programmatically change the stuff inside of it ourselves. So we're going to set editable to be false. We're going to do that ourselves. And then the initial text for the text field is whatever the counter's count is, which will just be 0, but let's pretend we didn't know that. And so we're going to set the text to the text field to be whatever the count is, but it's got to be a string, because it's a text field. It's got to be text we put in this thing. So you convert it to a string with the integer.toString function. It's part of that library. So it's all very similar. It's just ideas, slightly different syntax for it. So that's how you do it. And then I found a nice helper function that changes the font size of these components to be huge so that we can see it on during lecture. The default font size is much smaller, but apparently this is how you do that. Got to do a bunch of weird stuff to set a font size, but you can look at that yourself. So that's the text field, and then I want to make 2 buttons, one for increment and one for reset. So here's how you make the increment button. You just say new J button. That'll be our ink button. Call it ink. Make the font huge, and then buttons, they need functionality. Like when you click this button, that's called an event happens in Java. The button's listening for that event. There's a lot of weird metaphors going on. But what I have to do is hook into that click. So it's called an action listener. I need to add an action listener to the ink button to have some code that runs whenever I click it. So this is just the syntax for that. All I want you to care about is this body of this inner method thing. These are the 2 lines that I tell the ink button, run these 2 things when you get clicked. Right? What do you want to happen when you get clicked? I want to increment the counter's count. So call ink on my underlying counter. And then that has changed the count. So set the text field to reflect that change. That's all you do. That's what I want to have happen when I click the ink button. That's also essentially what I want to have happen when I click the reset button. So when I make the reset button, make this font size huge. Same kind of thing, right? Just call reset this time instead of ink. And then most likely it was something other than 0 before, so always change the text field's text to reflect the current count. So that's pretty much it. And then I've set up those operations. I have not arranged everything in the window yet. So remember that I made the panel and I made the frame. By default, the window is not visible as you're building it. So it's invisible still right now. You haven't shown anything to the user yet, but let's put everything in there. So let's say panel.add. So I'm putting all the things in the panel right now in the order that I want them. So the text field first, then the ink button, then the reset button. That'll arrange those horizontally. And then I add them to the frame. So here I am adding the panel to the frame, which is the window itself. And then by default, the frame doesn't know, like it has 0 width and 0 height. So you tell it to pack itself, to like fit itself to the contents of what I put in there, so to the panel. And then by default, the window is invisible, but now I'm ready to show it to the user. I built it. Then you say set visible true to show it to the user. And so that's it. It's code that generates a window, and that's how that works. The reason for pack is because like by default, the window would be like this size or something. And so it just pack tells it to like resize it to exactly how wide these things want to be. No bigger, no smaller. So yeah, that's our counter GUI program. Isn't that fun? So I encourage you to play around with this. Make your own graphical user interface using the Swing library. Have some buttons that do cool stuff. Copy my code. So I'll give all this to you. Are there any questions about that? This may be a little over our heads right now, but hopefully you understand the ideas behind it, at least at a high level. It's just, this is a library. You learn the library and what you need to do to make something happen. But it's so nice that this is baked into Java. Gosh, I wish we had that for C++. So there's that. And then, yeah, if we're ready, let's do Python. Question first? Yeah.
Is there a way to do something similar with that with C++?
Yes, but you have to install a separate library. It's not part of the standard library. Swing for Java is part of the standard library, which is really cool. Yeah. So again, they have this page, learn X and Y minutes for Python this time. I encourage you to go here to start reading the file. Python is a great language to learn these days. I feel like Java's on the way out, but Python is here to stay. So read that if you're interested. We'll walk you through Python. And oh, by the way, just for fun, it's not like the mascot. Like you go to their website and you download Python. It is a snake, but Python was named after not the snake. It was named after the Monty Python comedy group, if you've heard of them. And so there's a lot of references to that in the documentation and in the language itself, which is kind of cute. Okay, let's do Hello World in Python. Obviously, that is necessary. So this is legitimately one line of code. There's a good reason why a lot of schools teach Python first, because all you have to do is make a file. Usually it's .py for your Python files, and there's no such thing as a main function in Python. You just start typing. Like you type a line of code, and it will run that line of code. So all I have to say is print. It's called the print function. I say hello world, hello ... That is hello world. Isn't that amazing? So Python, you just start writing code, and so here's that. Let's make a new file. Then hello.py. So what we'll do is I will say print function, and I'll say hello, comma space world, exclamation point. Boop, just like that. Single file, or single line file. And you just start writing code, and Python will run every line. That's how it works. That's essentially your main function. So yeah, it's a lot easier to get students up and running if you teach them Python first. Sorry, we did it the hard way with you guys. So to run this file, you run it in Python. There's no concept of compilation for Python. You just say Python, and it's Python 3, by the way. That's the version that is the recent one. So it's Python 3, and then you give the name of the file, hello.py, and it will run that to completion, just every line. And so that's how you do it. So that's that. Any questions about that? Very easy, right? There's no semicolons in Python. Comments, they're not double slashes for a single line comment. It's a number sign, just like makefile comments. This is a single line comment. Multi-line comments start with are delimited with 3 quotes, either single quotes or double quotes. So 3 quotes on each side. This could either be single quotes or double quotes, by the way. So this is a multi-line comment. Okay. So obviously that does not affect the program. Run it again. Those are just comments. So a little bit different. Kind of nice. Here's some main differences. So let's see, what do I want to do? Let me talk about them first, and then I'll go through it. So first major difference, Python has no compilation. Python is what's called an interpreted language. There's no concept of compilation to Python. It just is going to read your program line by line. If this is your program, Python is going to read it character by character. It's going to be like, all right, let me draw some stuff first. So, comment. Then you'd be like print 2 plus 2. Print high. So legitimately what Python does when you give it your program, it's like, all right, I will read character by character through this file. It sees the number sign, then it's like, all right, I will skip over the rest of this line until I find a new line. And then it starts reading the next line. It's like, all right, print, open brace. Okay, this is a call to the print function. What do they want to print? 2 plus sign 2. Okay, better evaluate that. Closing brace. Okay, that's what they wanted printed. Like, Python reads it character by character and figures out what to do, and then it's like, all right, print 4. Then it reads this line, print. Oh, they want to print something in. What do they want to print? Hi. So it's just got to learn it every time what you want. And that process is very slow. Reading it character by character. Every time you rerun this program, it's reading the character by character through the file. And so that's super slow. It is an order of magnitude slower at least compared to C++ and Java, the compiled languages. So like, you write the same program in C++ and Python, the C++ version will run 10 times faster. Maybe even more. Okay? So that is something to worry about, potentially. But honestly, these days, all the libraries, this is the secret. Like everybody does machine learning, for example, in Python. So the secret is you write the library in a low-level language like C++ or Java, and then you have Python functions in that library that call to C++ or C. That's the secret. And so it can run fast things still if you just have the libraries secretly be implemented like that. So that's fine. But that's one thing. Actually, let me write some stuff. No, let me explain it more and then I'll write it. It's a little weird. I don't know about the order, but okay. One thing about Python, is that it's dynamically typed. We say so. Python, you don't say type names anywhere. You just say, give me this, set this variable to this, and it figures out. Okay, that must have been a string. Python will figure out types for you, and if you mess up, that means, right? First of all, there's no compilation process. So if you do something wrong in Python, usually what would have been a compiler error in C++ or Java becomes a runtime error in Python, which is kind of funny. And then because there's no types anywhere to make a function, you start saying def all over the place. So I think I should, let me start with that. Let's make some Python, and just like I did more Java last time, let's do more Python this time. And just like Java loves the camel case, like you capitalize the new words, Python loves the underscore to separate words. So I'll try and do that. So, okay. So here's one thing. There are no types that need to be declared in Python. Python still knows like something's in it or whatever, but it'll figure them out for you. It just figures them out. So here's this. So x equals 42. Here's how you make a variable called x. You say it and you give it a value. You shove a value into it. There's no types. You don't say type anywhere. And then you say print x. Sorry. No semicolons, but I will accidentally type them, I'm sure. That's our 42, obvious. But it does know the type. There's a function called type. Type of x that you can print out that. So Python does know, like, x is an int. Here's proof. It's like, oh yeah, that was an int. But it just doesn't care. So I'm about to do something that's going to make you feel very uneasy. Python does not care. Boop. Oh gosh. Let's do it in order. I just put a string into what used to be an int. Python's happy with that. It's like, sure, now it holds a string. I'm fine with that. So that should make you feel uneasy, but Python does not care. X is now a string. Sure. It's dynamically typed on the fly, like whatever it becomes, it figures it out. It makes it work. To make a function, let's make a silly add1 function. Here's how I'll use it. Print add1 of like 42, so it'll print 43. Here's how you make a function, because there's no return type. How you mark to Python that we're going to make a function right now? You say def. I'm about to define a function to Python. You don't give any return type. Like, you can return something. It'll accept that, but you just say def, and you give the name of the function, and then you give the names of the parameters. Let's call this one y. Again, there's no type, so you just say y. And then you're done. There's no curly braces in Python. Instead, Python is all about white space. You're going to say a colon here, and then you're going to tab over. And everything that is indented is the body. We only need one thing in the body. So everything that's indented is the body of the function, which is really nice, actually. Less typing. And usually your editor tabs over for you. And like return y plus 1. And then once you unindent, it just knows you're done with the function. So you're kind of forced to write clean-looking code in Python, because otherwise it wouldn't understand it. That's another nice thing about teaching that first. So there's our 43. Does that make sense? So because types are not very important in the Python language, then we do it this way. All right, so no return types, just def. So white space really matters. You want a body of something, you tab over. No braces, just white space. Instead of arrays, to like hold a bunch of stuff, there are libraries that introduce arrays, but lists is what Python cares about. It looks kind of like an array though. So L equals 1, 2, 3. That's a list in Python. So the following is a list, and let me just make you feel uneasy again. You can do that. So strings, also strings in Python. Strings can use. There's no concept of a single character in Python. You can either use a single quote or a double quote for strings. It doesn't care. So you can either use these or these for your strings. Python does not care. So you don't have to type shift if you don't want to. And then, so this is a list, and it works kind of like an array. Like you get indices. So you can print I like this. Indices start at 0 as usual. So there's that. I'll show you bodies of stuff. Instead of else if, they're like, that's too much typing, and so they say elif instead. So let me show you that. So let's make like a grade calculation program. If I do this, like grade equals 77 or something. And so like you have an if else statement to like calculate grades, but it will become an if elif else in Python. So it's like if grade greater than or equal to 90, you don't need parentheses in your if statements. Print A, and then it's elif. Let's just do AC or F. Elif grade is greater than or equal to 70. Print C else. Print F. So that's how Python works. You're required to have multiple lines because like you have to finish your thoughts because there's no semicolons. Like it's all white space driven, which is really nice. It forces your code to look a bit cleaner than I've seen some of your code in Vim for C++. Okay, that's kind of nice. It forces you to indent. Otherwise, it won't do the right thing. So there's that. Another thing about Python, I'll show you this when we make a counter class, is when you're making classes, and I'll show you that. When you're making classes, you have to explicitly talk about this parameter that was secret for C++. And they call it self. So kind of like how I forced you to do that in that lab. So remember that when in C++, this is C++, when you say this, counter.inc, right? Secretly, that's calling counter ::inc, and even though this takes no arguments, it's secretly getting the object itself as the secret 0th argument. It's getting it by address. It's getting a pointer passed along, and that's your this. That's why you have access to a this parameter, a this variable inside of every method. In Python, you have to be very explicit about that this. You got to give it when you're defining your methods, and they call it self. That's the thing that they like to call it. All right. So let's make that. Let's make a counter class, and we'll make it work. So I think we'll call it counter.py. Boop. And so I'll just type it all over again. That's fine. It's easier this way. So let's pretend we have a counter class first of all. So here's how you make a counter object. Again, there's no type involved. I want to call it C, and I want to call the constructor. That's how you do it. There's no new, there's nothing like that. So that's how you're going to call a constructor. And then c.inc, let's inc it a few times. Again, no semicolons. Print c.getCount. That's how I want to use this class, right? So it should be printing 3 there. And then you can make another one with like c2, inc that a couple times. Oops, let's do a couple of those. Poop, so c2, c2.inc a few times. This one will be 2, or let's make a parameterized constructor. Let's be like 44, or no, 42 to make it 44. That's what I did last time. So inc it twice after that, then the counter's count should become 44. So that's kind of how I want to use this class. So let's make everything like that. So it's a little weird, but it's still very similar. So if I want a class called counter, I say class counter. And as you would expect, I put a colon, and I indent, and I give all the methods. All right? So it's the constructor. First new thing is it's the constructor in Python where you make your fields, where you make your member variables. You don't declare them anywhere. So you just start writing them in the constructor. The constructor is called, it's not the name of the class, it's called __init __. It's a weird thought, but that's okay. So this is going to call the constructor, but when you're writing it yourself, you got to say it like this, init __. And it's going to take, even though you don't give any parameters here, it's going to take self. See that? Secretly, it's going to be given there, and I have to do more, but let's write some comments first. So constructors in Python are called __init __. And then every method that you're going to write is going to explicitly take this self parameter. It's going to be how you access the current object. Every method takes an explicit self parameter first. But when you call it, it's automatically passed. But it's automatically passed when you call a method. Just when you define it, you got to give all this stuff. So I want this kind of constructor. I'll do this in a second. Let's comment that out. Let's just have the first kind of constructor. So that's just self by itself. And then we're going to make a field inside of this method, inside of the constructor. So let's make a field, member variable, called count. And so here's how you do it. All your fields get made in the constructor. And you can do weird stuff, like in an if statement, you can make some fields sometimes and some fields other times. Like they don't all have to exist. That's dynamic stuff, the dynamism of Python for you. So if I want to make a count member variable, I gotta do it like this. I gotta go through self.count. That's my current object. It's like a reference to it. Self.count equals 0 to start out, for example. So this line right here is where the member variable gets made. Which is weird to think about. So you say that, and the constructor creates the new counters. Okay, and then inc. Let's do inc and get count. Here's how they work. So def inc, it takes self. It takes the current object as an explicit parameter. And then what do you do to increment your count? You got to go through self again, self.count. There's sadly no plus plus in Python, but there is a plus equals, so that's the next easiest one to use. So plus equals 1, and then get count, def get count, again, takes yourself as a secret parameter, but it's explicit when you declare it, when you define it, return self.count. So that's the class implementation, but when you use it, you don't have to say self anywhere like this, just this syntax will gets translated into inc on C, essentially. That's what's going to go on. And so you're getting C, essentially, when you call inc, like self, C is self, and so it's like C.count plus equals 1. That's how it knows to affect that particular member variable. So that's that. Let's watch that work. Boop. There's the useful pieces, Python 3 counter. Did I call this capital counter? That was dumb. Usually it's lowercase, so let me... Oh gosh. Alright, since last change. Stop. Right, please. Quit. There we go. So let's call this lowercase counter.py. That's just, it feels better. It's more Python-like. Alright, so now Python 3 counter.py. And it prints 3 because we did that. And now let's also make a parameterized constructor. Oops. Let's make a parameterized constructor, and so let's give another argument. Default parameters do exist in Python. So we can do this. We can say count. And by default, it will be 0. And so self.count equals whatever the count was that was passed to us. So if we give nothing, it'll be set to 0 by default. If we give something, like here, if we give 42, it'll be passed along into the count variable, and it will be set like that. Self.count equals count. So either 0 if you don't give it, or something if you do give it. So there's a real parameter here now. But it comes after self. Self is implicit, but explicitly written when you're defining these methods. So let's see here. Did I miss something? Oh, sorry. Not C.getCount, but C2.getCount. Excuse me. So there's my 44. All right. So yeah, similar yet different again. Any questions about that? All right. So yeah, what's going on is like in C++, you're acting on your current object, and like it has a bunch of member variables. And just like in C++, when you call a method, there's always like a this set for you. That's a pointer to yourself. You think of self as very similar to that. Like the self thing is like a reference almost to your current object. There's a way of getting at your stuff, and then you got to go through that to make your methods work on that object, right? So yeah, I got a couple last examples to show you, and then that'll be that. So let me show you a library called the Turtle Library. This is really cute. It was invented back in the 70s, before Python, of course, as part of a programming language called Logo to teach kids programming. And so it's still really cool. I still force my CSCI 1 students to use this. It's so cool. It's called the Turtle Library. There's documentation for that. This is baked into Python. And what it is, it gives you the ability to draw cool stuff, make cool artwork. And so here's the metaphor. There's a turtle. Here's my best drawing of a turtle. And the turtle somehow got its tail dipped in ink. And it can respond to your commands, though. So you can tell the turtle to move forward, and like turn left 90 degrees, and move forward some more. And like you can tell him to pick his tail up, put his tail down, you make dotted lines. So that's kind of cool. So just with that and like changing colors, you can make a whole lot. So let me show you Turtle Graphics, the library. It's really cool. They are for drawing stuff programmatically. So when the program starts, when you use the Turtle Library, the turtle starts on the screen at the coordinate 0, 0, so the middle of the screen, facing to the right. So that's important. So let's draw some stuff with the Turtle Library. Let's draw like a square and a triangle. So let's see here. Dun, dun, dun. Turtle example.py. So I want to use the turtle library, so I'll say import turtle. It's going to be so cute. And then by default, the turtle is just an arrow. We can change the shape of the turtle to be a turtle. It's going to be the greatest thing ever. And then, so the turtle starts out at 0, 0, facing east. And just by asking him to do stuff, you can make it work. So here, let's draw a, what's it called? Let's do a square. So like here's the idea. If he's facing east already, like let's draw the first line first. Let's say go forward, Mr. Turtle, by like 100 units. And then he's here. All right, so let me show you that. So you say turtle.forward to make him move forward in his current direction. Turtle.forward 100 units. And then if you run that, I gotta do it over here though. Python 3 turtle example.py. Oh gosh, and then sorry, I have to say turtle.done at the very end. Just like please stay open, keep the window open after you're finished drawing Mr. Turtle. So there he goes. He moved to the right. He moved forward 100 units. Isn't that beautiful? And then for some reason I lost my mouse pointer. Lovely. Let's see. Can I Alt F4 that? That works for me. All right. So that keeps the window open. I really lost my mouse pointer. What if I do this? Do I get it back? Do I open the task manager? Apparently no. That's a bit of a problem for me. How do I get my mouse back? How did I do this before? So I love my computer. Let's see if I Control Alt Delete. There it goes. All right. So now the turtle's over here. We don't want him to go forward in that direction anymore. We want to make him like, cause he'd go this way some more. Let's make him turn left by 90 degrees and then go forward in that direction. That'll draw that part of the square. Yeah. Turtle dot left by 90 degrees, then go forward, and then I'll draw the first part of the square. Isn't that so cute? And of course I lost my mouse pointer again, but that's okay. So there's that, and let's see. So let's draw the whole square. Go here, and then again we go in this way, but we want to turn him left again, left 90, go forward 100. Again, he'd be like, then he's here, he'd be going that way, left 90 again, forward 100, then we draw a square. Yeah? And he's facing that way at the very end. So we just copy this stuff. Oops. Get out of here. A few times, I got a square. Beautiful. Isn't that lovely? And then you can change the color. You can be like, you can change the color to be like pink or something. You can say turtle dot pen color, give it a string of what color you want it to be, like pink. And it'll draw a pink square. So I'll show you that next time. But let's also do a triangle. So let's have the turtle like move down a little bit, go forward with his tail up, and then we'll draw a triangle here. So you have to remember geometry if you want to do this. So let's try to draw an equilateral triangle of a certain width. So first of all, does anybody remember what angles make up an equilateral triangle? What is every angle? 60? Good, yeah, because it's 180 over 3. So these are all 60. So that's beautiful. And so let's try and make that work. Dun, dun, dun. So if I want to move the turtle down to get somewhere new to draw, but I don't want him to make marks, because like he's facing downwards right now. Like, let's get him in place. Turtle dot forward 200. If I do this, he's going to make a mark. We don't like that. Watch. Boop. Now it's pink. And then, oh gosh. I didn't save it. Excuse me. I must not have saved it. Oh yeah, it's before done. Done needs to be the very last thing. So if I say this, this is just supposed to get him in place to draw the next thing. But see how he made a mark to get there? That's no fun. So what we do is we ask him to pick his tail up. So turtle dot up. So pick up your tail, please, and that'll work. And then put it down once he's in place. Turtle dot down, and so he's facing downwards right now. He's facing downwards, but let's say we want him to move right first. Let's make him turn left 90, and then go forward 100. That'll work. So turtle dot left 90, and then you can go forward 100, and maybe we'll make this one blue. A blue triangle. We change the pen color to blue. So that'll be the first part of it. Scrolling back and forth. There we go. And now we have to turn the turtle by that 60 degrees, right? Wink, wink. There's something non-obvious right now. So like, turn left 60 degrees. Is that what it should be? Turn left 60 degrees. And then go forward 100 again? Perhaps. Let's see. No. That was not enough. It's like you want to draw a hexagon or something. So the issue here was, got to remember your geometry. If the turtle was here, he was going to go that way. We need to turn him that much so he's facing that way. That's the complement or whatever, this supplementary angle, I don't remember. But it's 180 minus 60. That's how far we need to move this guy. Okay. And then the same happens here. Like you want to move, like he's facing this way, you want to turn him 180 minus 60. So that's what you do. 180 minus 60, and then go forward a few things. So this is, just imagine how cool this could be if you use the random library plus the turtle library to draw like weird abstract art. Make a bunch of random triangles and squares of different colors all over the place. Could be your new background. So yeah, that's that. Are there any questions about that before I show you fancier examples? So yeah, that's the turtle library. So Python has some cool stuff baked in. One last thing before I show you some cool stuff is Python has what's called a REPL, and so it's really nice for like quick math. If you just say Python 3 without giving it like a name of a file to run, it will work like this. It plops you into what's called the REPL, and that it gives you a little prompt, and that stands for the read, evaluate, print loop. So like if you want to do 2 plus 2, and you press enter, it will read that, evaluate it, print out the answer, and then get ready to do it all over again. So like you've seen me go here a lot to do math, and like Python can do some cool math. This is the to the power of operator in Python. It's like to the 100th power. You can figure that out very, very quickly. So that's fun. So that's the REPL, and you can write some codes, declare variables and stuff. That's pretty cool. So that's Python in a nutshell. Are there any questions about that? So now you know Java and Python after today, which is cool, in addition to C++. For my last just cool example of how cool you could make stuff in Turtle Land. Apparently, do you guys know that, let me just start it running. You know that t-shirt that all the hipsters like to wear with the Joy Division album cover? Apparently that was, you can make that in Python with the turtle library, first of all. So here's it running. It's trying to make the cool picture. But let me try and explain to you what's going on here and why we could make this programmatically. So apparently, like what this is from the album, if you've seen this before, it's a signal from what's called a pulsar. That's some celestial object, like some black hole somewhere. It's giving off electromagnetic radiation, and so somebody took readings of that back in the 70s, and here are the readings. And we can just tell the turtle, like, for each pulse of the pulsar, well, if the signal went upwards, move the turtle up. If the signal went downwards, move the turtle down. And so if you just do that with the same amount, you can recreate that exact example with a turtle, because why not? So, like, here's me building up a bunch of cool helper functions. Please read this if you're interested. It's very complicated. But, yeah, I'm going through the entire data piece, like that entire list of data, and I'm drawing some fuzzy lines. That's what I call them. And it's all with the turtle library. So you could get this complicated with your stuff. And it's still trying. This is a very computationally intensive process. So we'll let that work for now. And let me give you your last lab of the class, and then maybe it'll be done by that time. And then it's time to work. So here is your final lab, due December 1st, so last Friday of classes. Well, what are you doing? There it goes. It's going so slow right now because it's trying to draw with the turtle still. That was all that. So here's your last lab. It's about bitwise operations. Okay, so let's go to that code, take a look at it, and then maybe you can start it. Windows, start code 40. Was this 110? 10? So here's your code. You got all these things. Of course, there's a makefile now. You know that. And what you're going to do is you're going to implement bitops.cpp. So the header file declares everything. You're just going to implement every single function from that header file. So bitops.h, you're implementing all these things. Somebody's giving you a number, and you're testing if bit I of that number is set, giving back true if it is, false if it isn't. You're counting all the bits that are set to a 1 in some number, giving back how many. And then you're making one last function that takes a number by reference this time and says, I want bit I set, please. So you're going to change the value that was passed to you and set bit I of that number, and to a 1 if it wasn't a 1 already. Okay? So we've talked about how to do all that stuff. Now it's your time to do it. But here are all the stubs that you will fix, of course. And yeah, return true if bit I of some number is set. False otherwise. Return the number of bits that are set to 1 and count bits. Do you kind of see how you could use isBitSet 32 times for count bits? Like, make it easier on yourself. Question?
For isBitSet, do you want us to check if the number that we're is greater than 31?
No, I don't think I'm going to check for that in the tests. Yeah. No, don't worry about that. Pretend the user knows what they're doing. Yeah. Pretend that the precondition on I is it's between 0 and 31. Yeah, that's a good question. Yeah. And then set bit is like you're given a number, set bit I of that number to a 1 if it wasn't already. If it's a 1 already, just keep it like that. That's fine. Don't have to unset it or anything. So that's that, and I've given you some tests. So here's remember the order of bits. So bit 0 is the rightmost bit. Bit 1 is the second to rightmost bit. Remember all that stuff? So here's 7. 7 in binary is a bunch of zeros, and then 1, 1, 1 at the very end. So this is bit 0 is a 1, bit 1 is a 1, bit 2 is a 1, bit 3 and onwards up to 31 are zeros. Does that make sense? So 32 bits total in an int and an unsigned int. And yeah, so isBitSet will check if a certain bit is set. Count bits, for example, is gonna, on this 7, should give back 3, because there are exactly 3 bits that are set to a 1 in the number 7. There's a bunch of zeros, and then 3 1s towards the end. Okay? So count bits on 7 should return 3, for example. All right. And then set bit is going to change your number in place. So you're going to set bit I of a number to 1 using some shifting, right, and probably an OR operation. So that's that. And then I've written some tests for you. Get those to pass. The make file will compile this, by the way. You say make test bit ops or just make. But here's the test file. I've made you some tests already for each of these pieces. Just making sure it's all working. All that fun stuff. So 15, bit 0, 1, 2, and 3 of the number 15 are set, but every one onwards after that is not set. Okay? So all those things, those are there. Get those passing. And then your final job, or your final lab, is to write 2 more tests. All right? So make test bit ops. We'll compile it, run it, and then make 2 more tests, come up with some wild scenarios 2 more times, call assert true twice, and that will be your lab. Yeah, so you're turning in 2 files, the implementation, and then your new tests. And that's it. Any questions about that? All right, we made it. So yeah, the next week is just going to be review, but that is your last lab, and I think that's everything that I wanted to say.